Hello everyone, welcome to the new video of Tech Internals. This video we will cover a very real-time based application and the framework to handle those real-time data. So we are talking about Spark Streaming. So this video will cover Spark Streaming in detail. If you have not seen my previous video, please go and watch. I have covered a lot of other big data tools and technologies which will help you to build big data applications. And if you are not subscribed to the channel, please do subscribe so that I can bring these type of videos for you. Okay, so let's get started. Spark Streaming. So this is the framework to handle real-time data. If you have worked in big data, you have seen a lot of use cases, a lot of application now coming up to process the real-time data. You talk about banking application, you talk about real-time transactions coming in. To handle all these things, everyone wanted to have an application who can process data in real time. You can take a use case of banking applications where we are getting a real-time transactions. You want to build an application which can catch the fraudulent transactions. So you need a framework, or you need a technology to process this data in a fault-tolerant manner so that you can catch what are the fraudulent transactions and what are the genuine transactions. Okay, so Spark provides the way, it provides the framework to build these type of application, and it is very popular. If you're working in big data, you should definitely know these framework, and if you have not worked upon it, go to this video and so that you can get a basic understanding on that. Okay, so let's discuss about real-time data sources. What could be a data sources which will produce the real-time data? So you can think about real-time feeds like Twitter. You can think about the real-time applications like Facebook, or you can think about data files which are generating in real time, like this could be file sources, log files which are keep generating. Okay, you can think about different sources like Kafka. So these are the Kafka, as I in my previous video I have covered Kafka in detail, so you can go and check that. But Kafka is a real-time framework which is generating a real-time data. So these are different sources which are generating these data in real-time manner. But we need some framework, some application which can process the data and apply the complex or simple transformation and produce an output out of it. So you can think about a framework which can handle data in real-time manner and which can process data in real time and provide me the output so that I can take some relevant action on top of that. Okay, so Spark have a different APIs, and this is one of the APIs which is provided to process real-time data. So as part of the API, it provides there are two different API it provides. One is a Spark Streaming and one is the advanced version of that. It is called Structured Streaming. So in this video we will cover both of them. Okay, let's talk about the Spark Streaming, how it is allowing this one. So Spark Streaming is a framework which provide a high throughput, low latency, fault tolerant framework so that you can process real-time data. Okay, so even if my servers are down, I'm still able to process data. So how Spark handle those things? So Spark Streaming API is already abstraction on top of it, and inside it is supporting, or it is handling all those fault tolerance or all those replication, everything. Okay, so let's talk about how exactly the data flow happens. So what Spark Streaming does, it provides a way to read this input stream which are coming from different data sources. Okay, it reads those input stream and process those input stream and produce the output. Now to process it, it divide all those input stream into small chunks and provide a way to do operations on top of those chunks. As simple as it is. Read the input stream, divide into batches, do processing and produce the output on each batches. So the smallest level of building blocks for Spark Streaming is called D streams. Okay, we call it discretized stream. Okay, discrete streams. So these streams are like sequence of RDs. So you can assume that RD is a resilient data distributed data set which I have covered in a previous video. This RDs, the sequence of these RDs are called D streams. Okay, so data is coming in, it is divided into a D stream, and every D streams and it is getting processed in real time. Okay, let's go to next level. So D stream are, as I mentioned, is nothing, it's just a sequence of IDs. Now in Spark, on top of IDs you can do any application, like you can do reduce operation, you can do flat map operations, or you can do count operation, whatever operation you wanted you can do it. So it's normal ID, and you can change this D streams to a D streams or IDs into a next D stream or next set of D streams or next set of IDs, and produce as an output to the as a file system or a database, or you put into the dashboard, so you can show in dashboards as well. So this is the way it processes. Okay, so let's see how exactly Spark is when you write an application, how exactly you write it. So you initialize a context of Spark streaming, you initialize the context, you define that, okay, this is my data source. It could be file data source, it could be input streams, it could be socket. So let's talk about a web socket, where I create a web socket, a particular port which is generating a data in real time. So I have defined a Spark streaming. I have provided that, okay, this is the input stream it is coming from. Then at the I get a D stream object. When I get a D stream object, I am doing a flat map operation on top of it. I am converting that into a different format. Okay, I can do multiple transactions on top of that, and then I can finally store in somewhere. So if you see a code, I have initialized the context, I have provided that operation on top of RDs, and then there are some more code you can write down, and then the two important lines, the Spark streaming context dot start, and then Spark streaming context dot wait for what is there? You have to wait for termination. Okay, so these things we have defined. So these things when you define, so it will not start at time when we call the Spark streaming context start. At that time it starts, and this streaming context it started receiving data from that particular source, and it will do operations and will store the output to a particular location. Okay, so this is the basic way how it process. Now talk about a use case where I wanted to, instead of doing on each batch, each time frame, I wanted to do on multiple small batches, one operation on multiple small batches. Then Spark streaming provide a way we call it window function, okay, where you can define a window of last, like assume I need to do a batch operation or do a operation which is combining like last 10 seconds. So all the data which came in last 10 seconds, I have to use the data and I have to count the number of transactions in last 10 seconds. And how can I do it? I can create a window of last 10 seconds. Okay, so when I define a Spark streaming context, there is a you can write a code to define a window as well. So that window I have defined a 10 second. When define 10 second video, in the last 10 seconds, it will capture all those IDs which has came in last 10 seconds, and it will do operations out of it. So if you see this one, I have defined like also instead of 10 seconds, I'm taking a 3 second video. So every 3 seconds, I'm capturing all those IDs and I'm doing the operation on top of it. Okay, so this is called window function, where you want to do operations on a window of RDs. Okay, window of D stream. Okay, so this helps in lot of places where you want to find a fraudulent transactions in last 10 seconds or last 15 seconds or last 3 seconds. If a transaction have occurred from a particular customer which has gone beyond a particular amount, like if I set a business rule that okay, if in last 3 seconds customer has done transactions which has gone beyond 3000, then I will flag those transactions. Okay, so these type of use case you can handle it. Okay, so let's talk about another things, like okay, I mentioned it's a fault tolerance. So how exactly it handles the fault tolerance? Okay, so the other building block is called checkpointing. So how a Spark streaming does a checkpointing? So in Spark streaming, as you know, it's a distributed based application. You have multiple, so when you set up a Spark cluster, you have multiple machines and multiple resources which you need to handle. Okay, so how Spark streaming handles? So assume that you are running a Spark streaming application, and by some because of some network issue or because of some application issue, because some while Spark streaming it failed. Okay, so when it fails, it needs to, when the next time you want to start it, so it should start from that particular point. So to get rid of that, to handle that, Spark does a checkpointing. So you have to define a checkpointing directory. So what is checkpoint? It checkpoints the metadata and checkpoints the data. So metadata checkpoint means that okay, if a driver fails or if a Spark Streaming application fails, so where exactly what all metadata information was there, what all number of executed and all those configuration it holds into that metadata. Okay, it's called metadata checkpointing. And for data checkpointing, so it is helpful in that place where you have multiple RDs, dependent RDs, when RD1 is dependent on RD2, RD2 is dependent on RD3, like that. Okay, so one RD is dependent on previous RD. Okay, so if you not, so what it does because you know that when you do any operation on a particular RD, then only this whole DAG or whole RD got invoked and do the process. So to get rid that, okay, to do it at the end, Spark does that in between. So intermediately it calculates few of the RD and store data, so that if it fails, it can start from that particular instance or at particular RD, not from starting. Okay, so because it could be very big hierarchy of that one. Okay, so this is why that's the reason it needs data checkpoints. So checkpoints that those IDs, intermediate IDs at the particular folder or particular place which you define. So now to define checkpointing, you have to define that okay, this is the directory, you have to store the checkpoints, and then you start a streaming context. So this is the way Spark Streaming works. Okay, now what is the difference between then structured streaming? So Spark Streaming is doing whatever is wanted and doing all those things. Then why we need structured streaming? So with the evolution of Spark at Spark 2 versions like 2.3 or whatever new versions of Spark coming in. So with Spark 2.x version, so it has started introduce a new way of handling the streaming data. So previous one was good, but it has some drawbacks. First of all, it was doing in macro batches, so it was not in very real time, and second, it was not able to handle layered data. So okay, let me get a concept of let's first take about real-time processing. So if I mention that it is processing in micro batches currently in Spark Streaming, what structured streaming does, it put a structure on top of data. So it is like not on RDs, it is on data frames. So whenever a streaming of data comes in, it creates a data frame on top of the data. Okay, so whatever stream is coming out, it's a data frame, okay, on top of that particular data. And it is this data frame, you know, it has a schema. It's like you can understand as a table. So table has multiple columns. Okay, so you can understand that this data came in and a table is being created for that particular record. Now this table is unbounded, like it don't have any boundaries. So as soon as new data comes in, it is keep getting added into that particular table in real time. And you are not dividing into batches, you are start doing operation on top of it. Okay, so this is the way structured stream works. So if I have a table, if I have one row, two row, if I have new row coming, it will keep appending, and my operation will on top of this row. So this row will be included in that operation. If you have defined a window, so based on the window, it will keep doing the operation. So in this case, it's not dividing into batches, it is as soon as data is coming into doing operation on top of it. So that's why it is called real-time streaming and structured streaming. Data frame is much easier to handle as compared to RDs. You can do any operation on data frames. So that's why structured streaming more efficient and more easy to use to process the data. The next concept, when I mentioned why layered data happen. So assume that previously the Spark Streaming is way to handle data which is coming at that particular point. So even data is generated at like 2 hours before, but if it ingested now, so Spark Stream will consider it has came now. Okay, but if the data has generated 2 hours before, but that's the timestamp of that data, that is generation timestamp. But Spark Stream was handling it at the ingestion timestamp when data was got ingested. Whereas in structured streaming, they have gone through with this issue. They had, and so we know that in a streaming application, there are some applications, some producer which can generate data late, okay, which can generate in few seconds later. So then how to handle that? So you have to, so Spark Stream provides, a structured stream provides a way like called watermarking. Okay, so you can watermark, you can create a watermark and mention that within this 10 minutes, so you create a watermark of 10 minutes, within these 10 minutes, if a data which is come, so you can first of all, when you create a streaming context, you can define this is my column. So in the data, there is a column called, assume there is a column called timestamp. So this is a timestamp column, the data generation timestamp. Okay, you monitor that particular column. So if the data is coming at that particular time, use that timestamp. Don't use the ingestion timestamp or data. So use that particular timestamp which is in the data. So based on data timestamp, it will add into a window. So assume data came here at 1 o'clock, and then there is a old data of 12:30. So that data will go, just say it will not go on top of that, it will go into a particular bucket where it was like the bucket of 12:30. So it will go at that particular point. So this is a handling on late data. So this data belongs to 12:31, not the 1 o'clock one. So this is the way it will handle the late data arrival. And this it's very easy. It's able to handle it, and it's very handling the complex functionality which was not easy to handle. This is the way how Spark structured streaming works. Okay, so we talk about Spark streaming, we talk about structured streaming, and then how the application helps to. Okay, so I would end the video here. I hope this video you like this video. The way we have we know that how complex it is to handle the streaming application. I hope this video has helped to understand those concepts. Please like and subscribe the video so that I can create this type of content more for you. Okay, thanks a lot and happy learning.